They can't sneak up on me.
I'm going to sneak up on the e-learners. Go! All right, so we're going to do double or nothing. Okay, so if you have not opened this up, please open this up. Go to Google Drive and type in double or nothing. Oh, it's over here. Double or nothing, and we're going to go over all these. Let's stop watching Minecraft videos. Anyway. All right, so prophase. What happens in prophase? This is what you should have for prophase right here. This is what you should have for your first couple. So you should have 4 X's. It does not have to be in this exact order. It just needs to look somewhat like this. So you need to have 4 X's. And what do we call those X's? Yes? Chromosomes. Very good. Now, make sure that your reds are matching up with your reds. And your chromatids are all matching up. Now, again, they don't have to be exactly looking like this, just somewhat. And what happens in prophase? I'm covering it up. It's behind my head right now. But what happens in prophase? What happens in prophase? Quizzes tomorrow. Yeah, Carmen.
The chromatids come together.
Right. So chromosomes are forming. Very good. That's the big idea here. If you have something more than that, that's fine. But the main idea is that the chromosomes are forming. All right, metaphase. What happens at metaphase? Yeah. Right, chromosomes are lining up in the middle. And again, it doesn't have to be this exact order. It doesn't have to be what I have, red, green, but it needs to look like this. Just need to be in the middle is what I mean. Look, when I look at the board, it looks like I'm looking at my metaphase. It's like I'm a meteorologist. And over here, we got our metaphase.
You're like the weather person.
Literally what I just said.
Oh, I didn't know.
A meteorologist is a weather person.
Oh.
I'm going to cover this up again. All right, so then over here, we have anaphase. And what happens at anaphase? I need somebody else. Madison.
What?
Happens at anaphase.
Oh, they're like pulling apart.
Yeah, they're yeeted across the cell. Very good. The chromatids are yeeted across, so they should look like this. Okay, so anaphase should look like this. And again, it doesn't have to have like what I did, red, green. It just could be scrambled a little bit. But as long as you're showing that they're being yeeted. And if you have them flipped, like where they're pointing different directions, that's okay too. It's not a huge deal. Just know that they're kind of getting pulled apart. And right here, chromosomes have moved apart. Anaphase apart. Turn to someone and say, anaphase apart.
Anaphase apart.
Which reminds me, metaphase middle. Turn to somebody else and say, metaphase middle.
Metaphase middle.
I used to do this kind of things last year more, but there's like hardly anybody in my classes anymore, so it's kind of sad. I miss you guys. All right, telophase should look like this. This is telophase, so you should have your chromatids have been moved so far apart and your cell has been stretching, and you should have them on both sides. And also around, and on this drawing, it's not here, but you would have 2 new nuclei forming around the chromatids. All right, interphase, we're going back around. We skipped cytokinesis because the cells have pulled apart. For this activity, we just skipped that one, and we're going back to interphase. So this is our new daughter cell. In our interphase, it makes a copy of all the DNA. So I kind of gave away the info. It makes a copy of the DNA. So you should have all those chromatids just kind of floating around. Interphase is like where the cell lives. It just bees a cell. Bees a cell. That doesn't make sense.
Intermission.
Yeah. No, interphase, like intermission.
Oh.
Yeah, Carmen.
So after the process repeats, it goes back to the interphase.
Yep, it goes. Yeah, once it's divided, it goes back just to, well, not go back, but the new cells just to be a hair cell or be a skin cell or be a muscle cell or whatever type of cell it is. It lives in this phase the longest. Okay, and then once it goes through this phase, depending on the cell, how long it's there, but it goes through this phase of being a cell, living and being a hair cell or whatever it is. Then it goes into mitosis, and mitosis is the PMAX, the prophase, metaphase, anaphase, and telophase. It then goes through division. All right, then we go back to prophase. Again, this is all a cycle, so it's going to go back through again. In prophase, we have our chromosomes forming. So with prophase, how many X's or how many chromosomes do we see here? Christiana, how many chromosomes do we see? 4. Now let's go all the way back to the beginning. How many chromosomes do we see at the very beginning, Nathaniel? 4. So they have the same amount of chromosomes. Why is it that they have the same amount of chromosomes from the beginning to the end? What's the point of even dividing, Christiana? Yeah, we're making copies, okay? Again, what's the point of, or actually, hold on. So the definition of mitosis here is that it's the process in which the cell divides, producing 2 new cells, each with the same number of chromosomes and the exact type of chromosomes as the parent cell. Okay, so it just keeps producing the same information. You don't have to have this exact word for word, but just know that mitosis, it makes the same type of cell, same number of chromosomes and same information. Because you don't want to get a cut on your hand and then have hair cells growing there. Ew. Now, I do have hair cells. You know, I got hairy arms.
I don't think I want to see hairy arms. Mr. Jones, what are you doing?
Showing the hair on my arms.
No.
See? So there are hair cells there. You know what's really weird? If I had short sleeves on, the back of my arm right here is like crazy. It's so hairy. It's hairier than like any other part of my arm. And it's like long hairs. I'm just letting you know. I'll show you guys next time I wear a short sleeve. You know what? Uh-oh. Then we have... Hello. Not much. All right, then we have the next question. To compare the number of chromosomes from the parent cell with the daughter cell. And we already did that, right? So prophase, remember prophase 1 that we went through? That had how many chromosomes at the beginning? 4, good. And then at the end, how many did we have? Christiana, you answered that one, I think. Yep. And then we had 4. So the same number of chromosomes from the beginning to the end. Yeah. No. You want the same number? So it doubles in order to prepare for... Let me go back to that slide real quick. Hold on. I'll go back to that slide in a second. Hold on. So what you're asking is that interphase right here, they're doubling because it's going to prepare for cell division again. So it doubles so that each new cell can get information, the same information. Okay. So it doubles up temporarily, and then once it divides, then the 2 new cells have the information. So if I wanted to make a copy of the St. Baldrick's information, by the way, sign up for St. Baldrick's, okay? If I wanted to make a copy, okay, I need to double. I need to make a copy, and then I have 2 copies to give to everyone. Does that make sense? Yeah. Okay. All right, let me go back to that slide. We did this one, right? Yeah. Again, you don't have to have this word for word. I have a little bit more than you might need. All right, and then what is the point of mitosis? We talked about this briefly, okay? Again, hair cells. Remember I have hair on my arm, okay? To grow, or think of a sunflower, it grows, right? In order to do that, it needs to keep making copies of the cells. And then number 2, to replace dead or worn out cells. Again, like if you get a cut or you get a haircut even, it needs to replace those cells. You get your fingernails, they get replaced. That's why they get long. Okay, you get a cut on your hand, you might get scar tissue, but it's still skin cells. I point here because I have a nasty scar on my finger. I have one on my knee too.
What about your toe?
My toe, yes, I forgot about that. Thank you for reminding me. It actually hasn't been hurting. Should check on that. Remember when I ran over my toe recently for this unit? Okay, my toe is slowly growing back new toenail cells and toe cells. All right, so if you have 46, I'm going to cover up the answer. If you have 46 chromosomes in your body cells, which you do, all your hair, skin, nails, all of your cells have 46 chromosomes in each and every one of the cells. That's not 46 chromosomes in your entire body. That's every cell has 46 chromosomes. I know. That's a lot. A lot. So how many, if I cut my hand on accident, those new cells, how many chromosomes will each of those cells have? 46, whoever said that back there, yeah, 46, good. So I'll move my face here. Yeah, 46. Okay. Why is it 46? Andrew? Same number of what? Same number of chromosomes in the new cells. Yeah, Henry.
Are normal cells different from blood cells? Or are they kind
I mean, we have like nerve cells, we have brain cells. They all have 46 chromosomes because we're human, and all of our cells have 46, but they all have different jobs within our body. Does that make sense? Like your blood cells, they still have 46, but they obviously are blood cells. You wouldn't want those, or nails, or they do different tasks. Good question. And they don't all have the same lifespan. Like your nerves and things like that, they'll last. Your nervous system that lasts longer than your skin cells. Skin cells get reproduce a lot, and that's why your house gets dusty because your skin cells are shedding. All right. Yeah. Not 100% that, but that's part of it. All right, that is all for this review for remote learners. Hopefully, it's helped you. If you want to resubmit this, anybody, if you need to resubmit this later today, you can, or submit it for the first time. I haven't started grading these yet, so go ahead and do that because I know with map testing, I'm a little behind with grading, and I haven't seen half of my students since last Thursday. So, all right, that is all.